Okay, we're going to do question 2D from the 2017 paper, and it's an excellence question. And basically, it's a fancy, challenging question, but it's just basically a find the equation of the line, of the tangent line to the parabola at a certain point. That's all it is, without numbers. It's got constants, and it's got a point of negative k and k squared. But basically, this is a question which is just find the equation of the tangent line. And if we can find the equation of the tangent line, then we can figure out what the coordinate of B is, a point on that particular line. So some things that we need to remember. Remember that the gradient function, or a tangent, tells us the gradient of the curve at a particular point on that curve, right? That's what it tells us. So if we're going to find what the equation for the tangent line is, we're going to need things like the gradient of that tangent line and the y-intercept for that tangent line. And so that's where we got to kind of work from. So the first thing that we've got to do is find the gradient in terms of, obviously, k, because we don't actually know what a is. We don't have any numbers, so we're not going to be able to get a physical number for the gradient, but we can get an expression for the gradient. So in order to find gradient, we've got to differentiate. And so we take our initial parabola, which is f of x is equal to x squared. We differentiate it into f prime x is equal to 2x. Now, we've got a point, right, that's on that line, negative k and k squared. So all we do is we want to find the gradient at that point. So how do we find gradient at a particular point? Well, we substitute in the x value. In this case, the x is not a number, it's negative k. So we simply substitute in negative k for the x, and we get negative 2k, which is our gradient, right? That's the gradient. At that particular point, we don't know what k is, but we know that that's the gradient of that tangent at that particular point. Now, if we're going to find the equation for the tangent, then we need to use that gradient and substitute it into the old y is equal to mx plus c formula, right? And so in this case, the gradient is negative 2x, or 2k, sorry, which goes in front of the x plus c. We don't know what c is. And then we can use a point that's on that line to find c, again, all in expressions. So if a is negative k and k squared, then that's the y value. So we substitute in k squared for the y value is equal to negative 2k, which is the gradient, times x, which in this case the point is negative k plus c. And so we combine all that, and we get k squared is equal to 2k squared plus c. Positive now, which is nice. And then we rearrange, and we get an expression for c. c is equal to k squared minus 2k squared. And then when we combine that, we get a negative k squared. So we now have the equation in terms of k for that tangent line, right? So we know what that L line is. That's the equation in terms of k. Now, but that doesn't give us the coordinate point, right? Which is basically some value of x0. But it doesn't matter, because we know that to find the coordinate of B, we just make the line equal to 0 and solve. So we can find that x-intercept, basically. So the next thing to do is to take your line equation and make it equal to 0. Don't worry about the squares and all that stuff. This is a straight line, and this is its equation. It'd be like having 2x plus 7 is equal to 0, and solving for that, and you would get your x equals, when y is 0. So we're just basically finding the x-intercept. So we get that equals 0, and you can turn it positive if you want. So move everything over to the other side, and you'll get k squared plus 2k x equals 0. You factor out the k. You get k is 0, and k plus 2x is 0, so k is equal to negative 2x. Now, they tell you that they want you to write the coordinate, find the x-coordinate of B in terms of k, so it's not good enough to say k is equal to negative 2x. Can't stop there. The question is, find the x coordinate of b in terms of k. So in terms of k means x equals. In terms of k means x equals. So we just rearrange this and we get negative k over 2. So the line does not go through the origin. It goes through at negative k over 2.